In each of the ideal diode circuits shown in figure 4.4, V1 is a 1 kilohertz 5 volt peak sine wave. Sketch the waveform resulting at VO, the output, and what are the positive and negative peak values. Okay, so I'm gonna kind of just go through this without a script, and if you need more details on how an ideal diode works, check out my video on 4.1. And I'm also not gonna make super nice output sketches. I'm just gonna, whatever it is. So, okay. So, if V1 is this sine wave, and this is ground, then we could assume this is on during the positive cycle, right? And then when this is negative, this voltage is going to be lower than this voltage at 0. And so that would mean that the current would have to be conducting in the reverse direction, but that's not something that the ideal diode can physically do. So the output voltage would only be like this positive piece of the sine wave. And then when it's going negative, just be flat, and then we pop back up. And it would okay, and the peak would be 5 volts. It would be 5 volts because there isn't any voltage drop across a resistor or something between V1 and V out. When this is just a short, it's just 5 volts like that, right? So let's hop over to problem number 2. Same thing. So you can assume that these are going to be on when this voltage is negative. This would be 0, and let's say when the voltage goes negative, this is going to be lower than this, so a current would be conducting in that direction. So the output voltage would probably be like flat, and flat like that. And the peak again, it'd be -5 because you don't have any voltage drop. You know what I mean? Like if this is a short, there's no voltage drop or anything. So how about this one? I'd honestly just assume this one's always off because of the way they're configured, right? So let's say when this is positive, when this input voltage is positive, then that would be greater than the ground. So D2 would be on, but D1 would be off. And the inverse case would happen, the vice versa would happen, and it'd always end up off, so VO is just going to be off the whole time. How about this one? Honestly, I'd say that this one operates in the same way that this one operates because this is, again, if the diode just acts like a short circuit, then that's how it will work. So VO would be like this. Again, 5 volts. There's no drop or anything because they're ideal diodes, How about this case? Let's see. So during the positive piece of the sine wave, it would be greater than here, so you would have a current conducting, right? This would be off, but you'd still have the current conducting through this path. And then during the negative piece of the sine wave, this would be less than this, so you'd have the current popping in through here. And so at all times, you would have a short circuit connecting VI and VO. So VI and VO would be the same. It would just be the 5 volt peak sine wave. No voltage drop or anything. How about this one? Let's see. Honestly, I would say you could kind of I just thought about this right now. This is the same circuit as this. So it would act like this, but we've introduced this D1. And this D1 would kind of block the negative piece of the sine wave or whatever. So we can assume that the circuit's going to operate like this. Or we can conclude that the circuit's going to operate like that. Yeah, that's how it would work. What about this one? Okay, so this is the input sine wave or whatever. This is the input sine wave I'm drawing right now. And let's see. This is at ground. This is at 0 volts. So during the positive piece of the sine wave, this voltage is going to be greater than this voltage. So it would be conducting, right? And that's all good. And then what about during this negative part? Then this voltage would be less then this voltage, so it would have to be conducting in that direction, and that would not be good. So that's going to be an open circuit during that negative part. Okay, so let's go piece by piece, right? So during the positive part, this is going to be a short circuit, so this is going to be ground. And then during the negative part, this is going to be an open circuit, so this is all going to be connected, and this would be like that or whatever. Let's see. Yep. The peak would still be 5 volts. Peak would still be 5 volts, or negative 5 volts, or whatever. How about this one? This one's kind of cool looking. Piece by piece again. So during the positive part, let's see, the positive would be greater than 0 volts. Right, this positive part would be greater than 0 volts. So this would be conducting, and if this were conducting, this would be a short circuit. And if this were a short circuit, then VO would be equal to 0. So let's go ahead and just draw that now. And what about during the negative part of the voltage? That'd be smaller than that, 0 volts, so it would be conducting this way. And so that would be a short circuit. And if this were a short circuit, then it would always be 0, which is kind of interesting. Because who cares what's wrong, right? So what about this one? If VI is a positive sine wave, right? So when this is positive, it's going to be greater than that. Well, we can't conduct in that way, so it'd be off. And if it were off, this would be an open circuit. So then the voltage at VO would be just that positive part. And then during the negative part, this would be smaller than this, so it would conduct current. And you would see if this was a short circuit and we're conducting from 0 to negative 5 volts, we have 2 resistors creating a voltage divider, and so we go down like to negative 2.5 volts instead of 5 volts. And then how about this one? If we had this voltage input is a positive 5 volt sine wave or whatever, during the positive part, that'd be greater than this. So we would short and we would skip this resistor. So the output during that positive part would just be positive. And what about during the negative part? During the negative part, smaller, so 0 volts would be bigger than the negative number, so we can't conduct, so this would open circuit. If it's an open circuit, we can ignore it. And we would look at this current now. This current would be from 0 to some negative part of the sine wave, and these 2 resistors would create a voltage divider. And then you would have a half of this negative part, so like again, this would go to negative 2.5, well, this is going up to 5. Okay, so we have the voltage, input voltage is positive and the negative, right? So I'm just going to go ahead and assume D1 is on. I'm just going to assume D1 is on, and that would make it a short circuit. So that would make this whole thing positive, right? And if this whole thing were positive, then there would be a current flowing through here, and that would short this. And if this were shorted, the whole thing would be shorted. So during the positive part of VI, you're not going to get any contributions to the output voltage. What about during the negative part? Okay, so again, I'm going to assume that this is on. And during this negative part, if this is negative and this is on, then this is going to be negative up here. And so this is going to be off. That's cool. And let's look at the rest of the circuit. We'll look up here. Know that we'll have a 1 milliamp current source always pushing a 1 milliamp through this 1 kilo ohm resistor. That's going to be a voltage drop of 1 volt. And if this is shorted, then this is all at the same voltage. So it's going to be like this, right? And so then if we want to get to VO, we're going to have to add that 1 volt that was dropped here. So VO, during the positive part, we didn't get any contributions, right? But we did get this 1 milliamp current pushing that 1 milliamp through the 1 kilo ohm resistor. And that would go through D2, and that's all totally cool. And so during the positive portion, it would be 1 volt, and then it would drop, you know, you add up the -5 and the 1, and then this would go to